Swayam Prabha. Digital India. Educated India.
Okay, welcome to this video lecture on basic surveying. Now today we are in module 11 and this is our last lecture of module 11, that is lecture number 3. In lecture number 3, what all we will be covering, we will be talking today about the building setting out as well as road setting out. When I say road, I mean it could be a canal, it could be a railway line, it could be any corridor, sewer line also. So we will be talking some basic principles here, some basic steps, and those steps can be extrapolated to any application there in the field. What we have done so far, in our last lecture, we are talking about the curve setting out, why we need the curves, types of the curves, and then finally we saw some methods. And following those methods, it is possible that we can set out a curve there in the field. So now we will go for first building setting out. Okay, about the building setting out, what all steps will be involved there? As in the case of the curve, or in our very first lecture of this module, we talked about the basic principles of setting out. So the same principles we are going to use here also. In the case of the building setting out, the various steps will be, number 1, it is surveying of the site. So we are going to the field, the area where we have to construct our building, we'll make a map of that area, we'll measure the contours. Then on that map, what has been prepared, we are taking that to laboratory and planning the building and as well as designing the various elements of the building. Of course, when I say various elements, we also come out with a foundation plan. So that's the foundation plan, for example. So then the next step is this foundation plan needs to be transferred onto the ground. So we do setting out of the foundation plan. Well, while we are setting out the foundation plan, that means the horizontal control. In any setting out operation, there are again two things, horizontal control and vertical control. In the case of the building, we have done the horizontal control the moment we have set out the foundation plan. The next, we have to at every step see whether the building is really going vertical or not. So for any structure, we have to ensure its verticality. So again, we will be making use of surveying instruments or some surveying methods in order to ensure that the verticality is there in the structure. Okay. As a very first step, now let's start with the site survey. The site, it could be any site. It is selected by the owner of the building and he wants to construct his building there. So as a surveyor, you would go to the site and you'll observe, you'll make a map of that site, you'll map the undulations of the site. So for example, let us say a hypothetical site is over here, and in this site we can see there are different kinds of forest, water body, and a road, and this is just land which is available. So first of all, a map of this area will be made. The methods of the map we have already discussed. Now let us say this is the map, because planning a building on the site is not possible. Rather, we would like to do it on the map. So once the map is there, the building planner or the design engineer can come out with various kinds of outlines or the possibilities for the building. Well, it may be of this odd kind or it may be of a different design. Okay, so this will depend upon the requirement of the owner, what all is required. Let us say the final design which is selected is this. This is the final design which is selected. So what we are doing at the moment, we are putting this design or rather doing this design on the map, on our drawing board. So the building has been planned. That's the plan of the building. So right now if you go to the field, still in the field there is no building of course, but there in the field we have fortunately the control points, because in order to make a map of this area we made use of some control points. What was the method? Let us say the method used here was traversing. So this is a traversing, and using this traversing the build area was mapped. These control points are also on our map. Okay, so by making use of course this line is not possible if you are doing the measurements by tape, because we have to go there and it's a water body. However, we can measure this line if we have the EDMI. Well, then again in the ground, because we have these control points which were used for the mapping purpose, and these control points are also there in the map where the design has been done or where the planning has been done. So what we will do, by making use of these control points, we can now fix the corners of the building. It could be by any method. The method could be the method of intersection or the method of we measure the angle and we measure the distance. We say the polar coordinate method. So whatever the method, we are able to now fix there on the ground the corners of the building. So these corners have been fixed by making use of the control points which are available there. Okay, what is next now? In each of these corners of the building, we can now put some pegs. So I'm showing you the pegs here, and the building outline is like this. So basically at the moment we have set out the outline, the building outline. Once we have set out the building outline, we can also set out its various center lines, because we know the dimension, we know how thick are the walls. So the center line can be marked here as well as here, also here. So the center lines can be marked. But at the moment, this is the foundation plan actually. What we are setting out there on the field is the foundation plan. It is foundation plan. Now once the excavation starts, what will happen? This entire area will be excavated, or wherever the walls are. For example, the walls are there, or the footing, the foundation. So this entire area will be excavated. Now if this excavation is going on, what will happen? The pegs or the reference pegs which we had put here, for example this peg at A, B, C, D, E, at all these corners, these pegs will be dismantled. So these pegs will not remain there on the ground anymore. So if this is the case, what should we do? Because so far what we are able to do, by using the plan of the building which is on the map, and by taking the polar coordinate method or intersection method or any other method, we are able to transfer the corners of the building there onto the ground. Now these are the corners of the building and excavation is going to take place there. So these corners, if I put a peg, it's not going to remain there anymore, because the lot of soil will come out and the soil will be dumped next to it. So what to do? We need to have these outlines. We need to know where is the center line of the building, because once you are going for any footing, so you need to know where is the center line of the building or the center line of the foundation. So we need to know the center lines, we need to know the outlines of the foundation, and as well as we need them throughout the construction. Okay, so what we would like to do, we would like to do something there in the ground, so that even if the digging is taking place, still we can mark the outlines as well as the center line of the foundation. Now how this is realized, we'll see it now. In order to realize this, now over here we have again this entire shaded part is the wall or the footing, because this is the foundation plan. So this is the foundation plan here, which will be excavated now. What we do, we make use of a board which is called profile board. What this profile board is like? It is nothing but a wooden board with some support, and on this board we have some notches. These are being cut. So by use of some saw or whatever the mean, these have been cut. Or we can also, because this is just a way of marking on this board. As well as what we can do, we can also drive some nails here as our requirement in order to mark some point. So this is the batter board or profile board. Now, how we use this batter board or profile board in the ground? Well, we will use, this is, of course, we are drawing in plan. So a batter board or a profile board is put here, and we put a nail here, another nail here, another nail here. Similarly, one more batter board is put here, and this is connected on this side also, and we are putting the nails in these locations. Now location number 1, 2, 3. 1 and 3, these two corresponds to outline, and 2 is corresponding to the center line. Similarly here also, 1, 2, 3. So we have a nail here, we have a nail here, and we have a nail here. So by these nails, if I highlight these nail positions again, nail number 1, nail number 2, and nail number 3. And over here, nail number 1, nail number 2, and nail number 3. So these nails or these the cuts on the board are basically the locations of the outlines and the center line. Now what we can do, by making use of a batter board here and a batter board here, because we have put them at both the ends. At any moment, at any time, we can stretch a string. So if I connect nail number 2 here and the nail number 2 here by a string, I will draw this string a bit thick so to make it clear. So this is the string which I am drawing here. So if we join them by a string, this basically marks the center line. Similarly here also, we can do in this direction. A string is put, the batter board is here, and we have the center line. So this is the center line over here. So what we are doing, even if this area is being dug, now which area? The area I highlight, the entire area, this area will be excavated, but still we have our batter boards. Our batter boards are here and here, and they are able to give us the directions and the locations of the center line and the outline. So this is how we can set a foundation, or set, this is the operation of setting out for the foundation plan. So these profile boards will remain there throughout, because we will make use of these whenever the footing is also going on to check the alignment of the footing. So these profile boards will always stay there. So this is just one example how we are making use of simple profile boards in order to set out a building or the building foundation plan. Well, next we will see the vertical control. The vertical control means now we are talking in vertical. So we want to ensure the verticality of a structure. Well, we can use a heavy plumb bob. Why it is heavy? It should be very obvious, because it should not swing with the wind. And over here in this diagram, you can see over here we have a building here, and we want to ensure the verticality of the wall, this particular wall, whether it is vertical or not. Well, what is done, from the base of the wall at certain distance D, a peg is driven, and we suspend a plumb bob. This is the string of the plumb, and here is the plumb bob. It is heavy plumb bob. So this plumb bob is suspended so that it is exactly over the peg here. Then the distance from the plumb line to the wall of the building D is compared with the distance there at the bottom. If these two distances are same, then the wall here is vertical. If it is not so, the wall will not be vertical and it can be assessed. Well, there could be another method. Use of plumb bob has got some problem, because if the building is too tall, we can't use the plumb bob. If the building is 2-story, fine, using plumb bob is all right. Then if there is a lot of wind, we cannot use the plumb bob. And there is inaccuracy involved in making the things vertical using the plumb bob, because they are on the top of the building also. If you are suspending the plumb bob, we may swing a little bit, and this distance, it is D, but the actual horizontal distance is not D. So those things may happen there. So it's not a very accurate method. And for very complex structure, we can't do it, large structures. So another method which we are seeing here now is the method based on theodolite. Well, what we do in this case, if we have a building, and because before the building was constructed, the foundation plan was there, and we want to ensure now the verticality of various parts of the building. What should we do? For this building, on the sides of it, on both the sides, we will make one big line, which we say the center line of the building, and as well as this way, the center line of the building at right angles to each other. And these center lines somehow we will transfer towards the top. How that is done? Let's do it now. If you look at the video, over here we have a foundation plan. This is the foundation plan, and for this foundation plan we have drawn the center lines. How the center lines have been marked? The center lines have been marked by putting two pegs, peg number 1, peg number 2, peg number 3 and peg number 4. So 2 pegs on both the sides of the center line. So 1, 2, 3 and 4. Similarly here also 1, 2, 3 and 4. And we can consider this as, it need not to be, but well, let's say this is this center point of the building. Now, as the building is coming up, because what we are seeing right now is the foundation plan. As the building is coming up, we would like to see the various parts, whether they are following the verticality or not, or is there any problem. So how we can do it? We will use the theodolite, keep it on one of the pegs. Let us see how we can do it. So we use the theodolite, for example here, and keep it here. Then we also know the center point of this peg and the center point of this peg means where this line is going. Then by bisecting the point here, we can now, because this theodolite is centered over here and we are bisecting this point. Now if I raise my theodolite, raising means I am elevating the telescope. So after bisection, I am elevating the telescope. If I am taking, so wherever I am taking it, basically I am looking along the line which is marked by point 1 and 2. So what we can do, wherever this line is going, I can put points there on the walls of the building. So various parts of the building, I can put the points there. So this is one part. Then second, I can do this exercise from here also. So what I am doing, well, let us say we are locating these points on the building, or if you draw it now separately, let us say we have a building, and this building I am drawing now in perspective. Let us say building is of this shape, and these are the walls of the building. So these are the walls. I have simplified it in order to understand it. Now the points which are there on the ground, peg number 1, peg number 2, similarly here 3 and 4, and also on this side peg number 1, peg number 2, and here 3 and 4. And what they do basically, if you join these, they intersect at the center of the building. This is what we ensured before the building was being erected. Now we are keeping our theodolite here, bisecting this, and then by raising the theodolite I can put various points here on the wall. Similarly from this direction also, and from here also. So there on the building I will draw it a bit thick. So we have a point here, a point here, and a point here, and a point here. So these are the 4 points which are coming from 4 directions. Once we have these points, what we can do, we can stretch strings, and the intersection of these strings will be the same point as there on the ground. So basically what we are able to do that by this method, a point which was the center point there on the ground, we are able to transfer it up. As well as once we have these strings there, when I say strings, it could be any other way of making the line of sights, maybe some telescope. So strings are just to indicate the line of sights. We can have, of course, physical strings also. Now thereon, once the strings are there, I can start measuring the offsets also from this string. Offset means I can start measuring the various distances or various features. So this will help us to ensure whether we are really going vertically up or not. Now if there is a very long column, another way of doing it, we can also make use of a theodolite. For example, if there is a very long column, we can bisect the top of the column by a theodolite. A theodolite is kept somewhere here, and I am bisecting the top of the theodolite and I am lowering it. Lowering it means I am bringing it down like this. Now we know it, once the theodolite is properly leveled and also it is adjusted, okay, then if I bisect a point there, I bring the theodolite down or bring the telescope down. So this plane which I am forming should be a vertical plane. If there is problem in the theodolite, we need to do this exercise on both the faces, face left and face right. But by doing this exercise, it should be possible that we can ensure whether a particular structure is vertical or not. And this exercise is not that simple. If you are talking of a single structure like this column, and in plan the column is like this, we need to do this exercise from different directions. Doing it from only one direction will not give the right result, because if we have a column here and the column is tilted like this, and if I am keeping my theodolite also here, so my theodolite will not be able to judge whether the column is tilted or not. I need to keep the theodolite in the other direction also. Okay, so these are the small things which we should consider, which we should keep in mind when we are working in the field. Fine, we have one more instrument here which we say autoplumb, and this is basically using some optical train in order to ensure verticality. Now we will follow the line diagram here, and it is basically, very accurate. It will give you only 1 millimeter error in a height of 200 meter. So it's a very small error, 1 millimeter in 200 meter. So it's a very precise instrument. So whenever a very large structure is there or high precision is required in transferring the vertical, we would like to use this kind of instrument. Now what is the line diagram? If you look here, well, down there is a point, and which we say is our point there on the ground, which we need to transfer somewhere up. It may be a ceiling very far, so we need to transfer it there. Well, the way this instrument is made, this is the instrument here, and from the line diagram it is very clear. We first of all, take this instrument, we put it over the point which is there on the ground. Okay, put it means we center it. We center it over it. Once it is centered, we level it. Then only it is ensured, as in the case of the instrument, that we will see exactly above that point. So we center it, we level it. Next, so this instrument is centered and leveled. So it is exactly looking at the point here, which is the point which we need to transfer there. At this stage, the ray of light will travel like this, will get reflected and go to our eye. So basically what is happening in the process of centering, I am able to see the point there on the ground, and this instrument is also labeled. Somewhere in this instrument we will have the bubble tube, and we are making use of that for labeling. Fine. At this stage, through a different optical train, this train, we have the reflectance of light coming from here, again getting reflected and reaching our eye. At this stage, if I see from here, and provided that this line and this line are coincident, there is no deviation between these two, there is no eccentricity between this line and this line. In that case, the point there on the ground is vertically transferred up there. So in using the autoplumb, we are taking it to the field, putting it on the ground station, the point which we need to transfer up, and then centering it, leveling it. Then we look through the upper telescope and we will be able to see the point there. So that point is the point corresponding to the point there on the ground. So vertically up, as we have seen the principle of this. However, there is one problem. If this instrument is not adjusted, adjusted means we were assuming here, we are assuming that this line and this line, these two lines of sights are coincident. This is what we are assuming. There is no eccentricity between these two. If there is eccentricity between these two, for example here, this line is slightly inclined like this. I am exaggerating it, but it may happen that there is slight eccentricity here, E. Still, we can use this instrument. What we should do rather, we should do this operation in 4 quadrants. What is the meaning of that? This is the point there on the ground, and first I use this instrument in such a way that I am looking at from here, and correspondingly if I draw the roof over here and the point on the roof, let's say that's the roof, the corresponding point on the roof is somewhere here. That's the point. Next, what we do, we change the direction. Now we keep our instrument in such a way that we are doing the same operation from 90 degree apart. If there is no error in instrument, our next operation will also result in the same point. So basically what we are doing, once we have taken the instrument to this side, again we are looking at this ground point and trying to find a point there on the rooftop. So if there is no error, we will get the same point on the rooftop. However, if there is error, we will get a different point. Well, we repeat this exercise again. Now we keep the instrument in such a way like this, and then finally also in this fashion. So basically we are doing it in 4 quadrants, and if there is error, we might get the points like this. So by joining these, the center of this is the point which is exactly over our point there on the ground. So even if there is error, we can still transfer the point there on the ground. But yes, it is advisable that we should check this instrument. This is also a check for the instrument, and we should adjust this instrument as we have discussed in case of theodolite. Okay, now after seeing the building setting out, we will go for another important area, and this is setting out of road. So as I said in the beginning also, setting out of road is similar to setting out of a sewer line, setting out of a oil and gas pipeline, or maybe setting out of a canal also, setting out of a railway line also. Though yes, there are minor differences between all these, but the basic principles will remain same. So in setting out of a road, what all steps are involved? Of course, as we know, if we have to plan the road between 2 points, so what we do? Initially, we will have a map of the area. In that map, we will have alternate routes, various possible ones, and then we will go for the best possible one, which we say the optimum one. Once that has been decided, it is marked on the map, and that particular area, that corridor, is also mapped, also surveyed very rigorously. The meaning is, we have in planimetry all the details, all the things, where are the forests, where is the water body, where is the river, isn't it? Where are the existing roads, where are the villages. We have all these features, as well as we have the contours. So contours are very important in case of a road, because we know the road has to go up, has to go down. So we will try to fix the formation of the road. Formation means the surface of the road. We will try to fix it in such a way that we have, as we have seen before also, minimum cost in terms of cutting and filling. And there are many more criteria which are involved into that, in fixing the formation of the road, the design criteria which are there. So basically, once that road is marked on that map, a very detailed map, then that map is being worked there in the laboratory or in the office. So those points are so far on the map. Next, we'll have to transfer these points onto the ground. Then we will see now, they are not only the center lines. It's not only the center line which needs to be transferred onto the ground. Rather, many more things. What are these? The various components of setting out road. Well, let's look one by one. First one we say, of course, we want to set out the stakes along center line. What is a stake? A stake is a term which is used for a pad where some information is written. At this particular point, how much excavation is to be carried out or how much filling is to be done. And this stake or this peg also marks a particular location there in the ground. For example, the center line. We also want to set out the stakes for defining the formation width. Again, we will discuss this formation width in a moment. Then also we want to set out these stakes, which is slope stakes, to locate the points where the road slope meets ground. Then finally, we would like to set out the slope rail. These are called the slope rail. Now what these are, we'll look at them. Okay, first of all, as we discussed, if we have a map, on this map we had various contours. Of course, the contours should not intersect. So I will delete it like this. These are the contours here, and as well as we will have their values written there. Maybe 30, 20, 10, 30, 40, 50, 60, 70. So these are the contours, and on this, the center line of the road has been planned. Okay, it is decided that the road will go like this. A decision has been taken. So now we are transferring first of all these center points or the alignment of the road there on the ground. So the center line means a peg. See, look at here. This purple line is the ground, is the raw ground, and this is the ground which is plotted here. This is the ground which is plotted. So far, there is no road on that ground. So initially, when we go to the field, we don't have any road, of course, and we have only the ground like this. But now by making use of the map, for example here, at this location, we have a center line point, and we will try to locate this with the help of the control points, because we have the control points also, as we have discussed previously. And whatever the method, this method could be by total station, or by the only tape, or by intersection by the theodolite, alpha 1, beta 1, whatever the way, we are locating this point there on the ground. So let us say this is the one peg, and this peg shows you the center line. So the center line passes from here, and this is cross section. Next, in the design itself, it was decided that at this particular location, what is the formation of the road? There in the design stage only, because road has to follow some particular gradient. The road has to go along some particular curve. So road cannot stick to the ground. Rather, road will be either slightly above it, below it, or even if it sticks to the ground, at some point it will deviate a little bit. So the surface of the road is the formation level, and that formation level is also being given by the design. So at every point, a particular formation level is being given. So at this point over here, a particular formation level has been given, and let us say the formation level here is like this, and as well as this is also coming from the design. So these lines, that's the formation level, and here the slope, another slope. So this is also coming from design. So far we don't have this formation level with us. So far we don't have this formation level with us. But what our job is? The job is we want to construct the road as per this formation level. We know only the center point at the moment. So next step is we would like to fix the formation width. Well, moving perpendicular from the center point, we can now fix there on the ground 2 more pegs, and these pegs are for the formation width. So we have now the pegs, we can say this as C, and this is D, and this is E. Well, once we are starting the construction, so at this point we need to fill it up. So we need to, because in order to raise the ground, we have to do all this filling up. While over here, we need to cut. So we give this information on these stakes also about the amount of cut and fill which is required. One more thing. At this moment, we know only from the design that this slope is, for example, 1:n. This is the information which is known to us, but we do not know where this point exactly will meet the ground. This is also important here, because once the contouring was done in the field and this formation level has been decided on the basis of the contours there on the ground, okay, it has been taken into account, but the point here where this slope will meet the ground, this point should be somewhere here. I can locate this point also by making use of the contours, but the contours are not that accurate. They don't represent the true ground. So what we would like to do, we would like to locate the point A and point B where the slope meets the ground, because that's the ground and the slope is meeting here at B and at A, also there in the field itself. So in our field, the basic job that we have is, we have to locate the center point, we have to locate the width, on the width, the two stakes there, and then finally, as per the cutting or filling, we have to find where the slope of the road, because if this is the formation, that's the slope, where it meets the ground. So that particular point also we need to locate, because to those people who are doing the construction, all this information needs to be given, and as well as we need to tell them, okay, from that point where the slope is, where we have put a point which we say the slope is stake, at what slope they should proceed further. So this information is the part of the setting out. Now how we do all this? First of all, the center point setting out, this is easy, and we have already discussed, we can make use of theodolite tape or total station, whatever, and we make use of the control points which are there on the map and also available on the ground, and we locate these center stakes. Now these may be located at 10-meter distance or 20 meter, depending what kind of terrain you are working. If there is change in gradient, because for example from here the gradient is changing of the ground, so we would like to have this distance even smaller as per the requirement. So these are the center line stakes. Once these are done, as we saw in the previous one also, we would like to locate the formation width stakes. So these are marked there on the ground. This is the center line, and they are the formation width stakes. And how we are doing it? From any point here, we are going perpendicular and we are going equal to the width of the road. And mind it please, equal to the width means we are going in the horizontal direction, obviously. Once this point is located, then our final step is to locate the point where the slope of the road meets the ground. So these points we have already seen for the width, for the slope, and for the center line. Okay. In the case of the slope stakes means over here I have represented the ground here, and that's the formation. So the slope stake has to be found here, has to be found here, has to be located here. And there may be different kinds of situation. It's totally on cutting, totally on filling, part cutting and part filling. And this is again no slope on the other end, but the slope here, and it's all in filling, all in cutting. So there could be different kinds of problems which one can face in the field. We would like to see only one of these now as an example. So at this moment we know how to locate the stakes for center line, how to locate the stakes for the formation width, and then the last thing that we would like to do is to locate the stakes for the slope, because we need these locations there on the ground in order to start construction, in order to start filling or cutting. Well, over here we have our ground here, and this red line, this is the formation, something which is coming from the design. The very first step, of course, we will locate the center line stake. So this is fixed. Then next we'll measure the distance equal to the width. So this is b by 2 and b by 2 if the width is b. So we can fix these two stakes also. Now we know that the slopes are 1:n. How these slopes are fixed? 1:n. Again, this is coming from the design. depending the requirement, depending the material which is being used here, this slope is fixed. Now we would like to know where we should begin our filling from. Is this a point here? 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 In the beginning, we do not know where from we should start filling. So how we go about it? Well, this is done by a method of trial and error. In this case, let us start from a point A dash. And right now we are using tape, level and staff. Of course, the same thing we can do also by total station. What we are trying to do, we are trying to see the basic principle here, the basic concept, and the same can be extended even if we are working with the total station. Well, we are standing at a point A dash with our staff. Next, there is a benchmark somewhere. Let us say the benchmark is somewhere here. This is benchmark. From design, I know the RL of formation. That we know. It's a known value to us. So we know the RL of this. We know from the design. Using the benchmark here, and we keep a label somewhere. Wherever, it doesn't matter. Just we need to carry out the measurements. We are keeping the label. Now, first we would like to keep, of course, there on the benchmark also our staff, and then from the label we will take a backside, and then on the staff which is kept here, we will take a foresight. We have already discussed these things, backside and foresight. By doing this backside and foresight, what we will be able to do, we will be able to determine the RL of a point where my staff is kept. So we know now RL of this point. We already know the RL of formation level, and now we know the RL of point A dash. Well, we can find the difference of RL of formation minus RL of A. So this we can find, as well as this C point is known on the ground, as well as we know A. So what I can do, I can measure the horizontal distance between these two. So this distance D is measured. From this D, I can subtract D minus 2. What does it do? It gives me the distance here. So we can say D minus D by 2 is the distance here. Fine. For this D minus D by 2, we already know difference of RL. Let us say the difference I write as delta RL, this divided by D minus D by 2. We compute this. If point A dash is exactly over the point where we want to be, then this will be 1:n, as we see over here, because we want a slope of 1:n. So if A dash is exactly over A, this slope will be the difference of RL divided by this distance will be exactly equal to 1 by n. However, it will not be so in the very first go. So what we would like to do, if it is not so, we would like to change the position of A. So what we do, we move this A now. We move this A to a different location. So this A is moved now here, and that's our staff. Again we do the same procedure. We take the back side and the foresight, and we determine the RL of this point, which is now A dash again. So we keep doing this process till we reach point A. So what we try to do in this case, by using dumpy level or any level and the staff and the tape, we started from an arbitrary point and we found the RL of that. We found the difference in RL of that point and the formation. And then we found, okay, from the corner of the road to that particular point, what is the slope which is possible in this case? If this slope is same as the slope which is desired, then this is our point. If it is not, then we'll have to move our point here and there. This particular exercise can be also done very well by using the total station. The concept will remain same. Of course, it is trial and error method, because there in the ground we have to locate that point. And what is our aim? Our aim is, finally when the road is constructed, the formation level should have certain RL. This slope should be the slope which is given by the design. So we are ensuring this by doing this staking process, by doing this setting out process, we are ensuring that the formation level will be at that RL and the slope will be along that slope. This we are ensuring here. Now one more term here, that is slope rails. So this is something, the people who are there in construction, they would like to make use of these slope rails. For example, if the ground is given here, that's our ground, and this is the desired formation with these slopes, 1:2 and 1 and 1:2 and 2. Now in order to help the people who are doing the filling, because this area is being filled, so once it is being filled, how much the filling should be? In order to control it, a very simple device can be used, which we say grade rod. It's a rod of finite height, and we move this rod along with a slope rail. Now how this slope rail is fixed, we can see the design of the slope rail made of some wooden planks. The only thing is, this edge of the slope rail is having the same slope as the slope down there. So if you are writing N2, 1:2 N2, so the slope over here, the slope of this edge is same as the slope of this. So what we can do now, we can now, after fixing this, someone can also sight from here, or by moving this grade road everywhere all along this, we can ensure whether we have done the filling equal to as it is desired or not. So basically this slope rail is a helping device. Not every time one has to make use of tape and other things, because we know from the slope rail our slope, which is the desired slope, is at this depth. So just by moving this rod over here, just by moving this rod, it is possible that we can now set our slope. Now one question which we partially discussed, can stakes be also located on map and then set out on the field? We partially discussed this. If this is our map, on this map we have the contours and we have also now the center line of the road marked here. Well, what we did, we transferred these center line points directly to the ground. What we can do while we are working on this map, because I know the undulations of the ground. Working on the map means I know the undulations of the ground. So I can also fix the width as well as the slope stakes here. because I know what is the slope in this direction. I know the slope in this direction, I know the slope in this direction, because once we have the contours, we have the 3D structure or three-dimensional structure of the ground with us. So using this map also I can fix these. And then as the procedure of setting out these center points on the ground, I can use the same procedure. For example, by making use of control points, I can also transfer these slope stakes there on the ground. But the question is, should it be done or not? If we do it this way, because our contour map is not very accurate, contour map, it does attempt to replicate the ground, represent the ground, but it cannot represent the ground very well. We don't have all the details of all the undulations. So this something which we are locating this way, there in the ground, it is possible that it will not give us the desired slopes. So what we are doing right now, we are on our contour map, we had located the slope stakes because we can do those computations there. And then we can transfer those slope stakes again by control points there on the ground. But because the contour map is not accurate, it will be observed now the slopes of the road which are being given by these set out points is not as per the design. So rather what we are doing, we are more importantly, setting out the formation, the slopes which is given by the design as such there on the ground. However, if we have very accurate data, for example, the data which is coming from the photogrammetry, or there is a new technique of LiDAR, we have the data which is coming from the LiDAR. In that case, because we have got full data, full digital elevation model is available with us. So if we make use of that data, on that data in our computer within the laboratory, we can do this staking, and then we can transfer that onto the ground and then check whether it needs to be shifted a little bit here and there so that we have this slope as per the design. So what we discussed today, we discussed about the building setting out, the basic principles of that, foundation, verticality, the instruments which can use, and then in the case of the road, what we desire in the case of the road. In the case of the road, we desire to set out the road in such a way that it follows the, or rather it is same as the design. We have seen some procedures, we need to set out the center line, formation, and then the slopes. Thank you.